Algebra 2, Set 2, Negative Exponents, Product and Power Theorems for Exponents, and Circle Relationships. Okay, so we'll start with negative exponents. So if you have a number that is raised to a negative power, what you do is you write it as 1 over the number to the power, but this time the power is positive. So x to the negative n is equal to 1 over x to the n. And n has to be a real number, and x cannot be equal to 0. So simplify 1 over 3 to the negative 2 power. So in this case, the negative exponent is going to flip that fraction, so it's going to be 3 to the positive 2 power, and that is equal to 9. Part B, 3 to the negative 3rd power, so we're going to put that in a fraction and make the power positive. So it's 1 over 3 to the 3rd power, which is 1 over 27. Negative 3 to the negative 2 power. Now this negative that's out in front is going to stay out in front, so we'll just carry it over and write it out in front. And then 3 is what is affected by the power. So 3 to the negative 2 is 1 over 3 to the 2 power. So that's equal to negative 1/9. Now negative 3 to the negative 2 power, both the negative and the 3 are in parentheses, so the negative 2 applies to both the negative and the 3. So this one we write as 1 over negative 3 to the 2nd power, and negative 3 squared is 9, so the answer to this one is positive 1/9. Okay, so again, we have the negative 3 applied to the negative 3 power, but we also have this extra negative sign in front. So we'll just put that extra negative in front and then apply the negative 3 power. So it's going to be 1 over negative 3 to the 3rd power. And negative 3 times negative 3 times negative 3 is negative 27. So we have negative 1 over negative 27. So we end up with 1 over 27. Okay, so now we'll talk about the product theorem for exponents. If I have x to the m times x to the n, the product is going to be x to the m plus n. So basically when you're multiplying bases, the same bases to with powers, then you're going to add the powers. M and n have to be real numbers, and x is not equal to 0. Okay, so simplify. X squared y, x to the negative 5th, y to the negative 4th, x to the 5th, x to the 0. So the first thing I see is that x to the 0, or actually x to the negative 5th, x to the 5, those are opposites of each other. Negative 5 plus 5 is 0, so those are going to cancel out. X to the 0 is going to cancel out because it's equal to 1. So we're left with x squared, and then we have y to the 1 and y to the negative 4th. So that's going to be y to the negative 3. Okay, simplify. Now, this one's a little bit complicated, and the way I'm going to start it is by canceling out the negative exponents and flipping them and writing them as positive exponents. So x to the negative 10 goes to the denominator, and it's x to the positive 10. X to the negative 3 is going to go up, as is y to the negative 6, and then I'm going to take that y to the negative 3 and move it down. For me, it's just easier to deal with positive exponents than it is to deal with the negatives. So now, going along the top, I'm going to look at x, and I get x to the 7th power, and then with the y's, you can see I've got 3 of them here. I've got 1, 2, 3. So I have y to the 6th, y to the 1st, and y to the 5th. So that gives me y to the 12th power. Now on the bottom, I have x squared and x to the 10th, and then I have y to the 3rd and y to the 10th. So the last step is just to simplify from here. 7 minus 12, so I'm going to have x to the negative 5th, and 12 minus 13, y to the negative 1. Okay, power theorem for exponents. If I have x to the m raised to the n, then I get x to the mn. So if you have a power raised to a power, you multiply those powers. Okay, it's also true if you have multiple powers, so x to the m, y to the a, z to the b, k to the c, and so on, raised to the n power is going to look like x to the mn, y to the an, z to the bn, k to the cn, and so on. So, for example, with this problem, we're just going to go straight across on the numerator, x times x to the negative 6 times y times x to the negative third times y to the positive 6. Negative 2 times negative 3 is positive 6. Now on the bottom, 2 times 3 is y to the 6th, and then we'll just write y to the negative third, and 2 times 3 again is 6, so x to the 6th. From here we can simplify. So we can cancel those y to the 6th, and looking at the top, we have positive 1, negative 6, and negative 3. So that makes x to the negative 8. And then we have a positive y. And on the bottom, we have x to the 6, y to the negative 3. So if we simplify this, if we move those x's to the bottom, we're going to have x to the negative 14. And if we move that y up to the top, we have y to the 4th power. Okay, circle relationship. So in this part, we'll be talking about area and circumference. And our problem says the area of a circle is 12.2 meters squared. What is the approximate circumference? So we know the area is pi r squared, and we're given that the area is 12.2. So we just set 12.2 to pi r squared and see if we can figure out what the radius is. So we divide by pi and then square root. So we get r is equal to the square root of 12.2 divided by pi. From here, you can plug that into your calculator, and you get the radius is approximately 1.97 meters. So now that we know the radius, we can figure out the circumference. So the circumference is 2 pi times the radius. So in other words, 2 pi times 1.97. Plug that into your calculator and you get 12.38 meters. So the approximate circumference is 12.38 meters. We'll do another problem. The circumference of a circle is 8 pi centimeters. What is the area of the circle? So now we're going the other way, circumference. So we know circumference is equal to 2 pi r. And from the problem, we have a circle that has an 8 pi circumference. So 8 pi is equal to 2 pi r. If we divide both sides by 2 pi, we get 4. So the radius is 4 centimeters. Now the problem is in terms of pi, so we can leave our answer in terms of pi for the next part. So it says, what's the area? So the area, again, is pi r squared, and our r is 4, so r squared is going to be 16. So 16 pi centimeters squared is our area.